we actually just did this. This was combining Judy and Pete's tables here, and this is what you should have got above. Now what they want is they want the mean of t, the variance of t, and the standard deviation. So this is going to be my L1, that's my L2, and you're going to do a stat calc, and then you're going to do like a 1 var stat. When you punch that in, please make sure you do, L1 comma L2, and what you get there is, so this is, remember, the number of passengers they're carrying, and if you look at that, the number of passengers that they're carrying, the expected value mean is going to go ahead and it's going to be 6.85. So that's how much they're actually going to be expected to have combined. And that makes sense because earlier Pete was expected to have 3.75 and Judy was expected to have 3.10. And when you go ahead and add two things, it's as simple as adding the two means for 6.85. But one simply does not add the standard deviations. And I believe the variance of this thing was, if I remember correctly, the variance of Pete was 1.1875 and the variance of Judy was 0.89. So what we need to do there is, since we have the two variances, we could actually add the variances and then take the square root, and that will give us the standard deviation. And the standard deviation for both of them is 1.441. What that means, more importantly, what's the standard deviation means, it's get rid of, it's the number of passengers will vary from the mean / expected value. Expected value was 6.85 passengers. So the number of passengers will vary from the mean or expected value by about 1.441 passengers. It's going to be very critical that you could always go ahead and keep that in context. What they give you the math scores and they give you the reading scores, and they say like, hey, what's x plus y for this randomly selected application? So the mean is as simple as going ahead and adding them. Math is 519, critical reading is 507. So what we get is our new mean is, sorry, that's a plus sign, is going to be 1026. Now, many of you are probably jumping on this standard deviation and saying, okay, take this standard deviation squared plus this squared, and this will give me my new variance, because but remember, our rules only work if things are independent. And I want you to go ahead and think about math scores and reading scores. If you're scoring well on math, you're probably more than likely scoring well on reading. Those things are not independent events. And that's the critical thing with this, is since these aren't independent, we actually cannot, there's not enough information to calculate the variance in the new standard deviation. So essentially all we're left with is this right here for the new mean. We're back on Pete and Judy here. This is the mean of Pete. Pete has 3.75 passengers with a standard deviation of 1.089. Judy has 3.1, standard deviation of 0.943. So if Pete charges 150 per passenger and Judy charges 175, let's find the mean of Pete. In money. So we know that if he gets about 3.75 passengers and he gets $150 per passenger, then this will be Pete's mean. And if you go ahead and calculate that out, it's $562.50. Now let's go ahead and do Judy. She's 3.10, but Judy doesn't charge 150, she charges 175. So calculate that out, that's $542.50. And the problem asked, calculate the mean and standard deviation of the total amount that Pete and I don't know why that says Aaron, Judy collect on a randomly chosen day. So we are allowed to go ahead and add those. So if you look at that, all we need to do is add up our means, and the expected value they're going to get is $1,105 is the new mean. And then we need to find the new variance. And this would be the equation for variance. Now we could actually go ahead and do this because Pete and Judy's thing are independent. They're in different parts of the country. So what you need to do is, if Pete's is 1.0897 squared and Judy's is 0.943 squared, so what we're going to be doing is calculating those numbers. And if you were to go ahead and get that, you would, oh, I actually made a mistake. We want to know how much money. So if the standard deviation is 1.0897 for Pete, but how much does he make per passenger? That's 150. So essentially the standard deviation in money for Pete is this right here. The standard deviation for Judy, 0.943, and she charges 175 because we're trying to figure this out in the amount of money that they're collecting, not the number of passengers. My apologies. So if you were to go ahead and figure out how many Judy is, she's about 165.03. Now what you could go ahead and do, this red one up top is your standard deviation. This is the standard deviation of Judy. The last step to this is the 163.46 squared plus 165.03 squared, and you would have to go ahead and calculate that. And you get your new variance to equal $53,954.07. To get the standard deviation, you guys know to take the square root, and it'd be 232.28. Once again, you need to keep it in context. The amount of money they collect will be about within $232.28 of the mean, that it will vary in between that.